This video will show you how to find the inverse Laplace transform by computing square and first shift. We are going to find the inverse Laplace transform of 4s plus 1 over s squared minus 2s plus 2. First, we are going to do computing square. And what does computing square says? We say that x squared plus a times x is equal to x plus a over 2 square minus a over 2 square. Similarly, x squared minus a times x equal to x minus a over 2 square minus a over 2 square. This is computing square. Now, we are going to look at s squared minus 2s plus 2. So, s squared minus 2s plus 2, if you compute the square of s squared minus 2s is s minus 2 over 2 square minus 2 over 2 square plus 2, which is s minus 1 square minus 1 square plus 2, which is equal to s minus 1 square plus 1. That is the denominator. So we are looking for inverse Laplace transform of s minus 1 square plus 1 in the denominator, and the numerator is 4s plus 1. Now, because s minus 1 appear in the denominator, we want to also make a copy of s minus 1 in the numerator. Let's focus on the numerator. The numerator is 4s plus 1 which is equal to 4 times s minus 1, which is 4s minus 4 plus 5, so that you have a copy of s minus 1 also in the numerator. That means we are trying to figure out the inverse Laplace transform of 4 times s minus 1 plus 5 over s minus 1 square plus 1. So, the inverse Laplace transform of 4s plus 1 over s squared minus 2s plus 2 is equal to the inverse Laplace transform of 4 times s minus 1 plus 5 after balancing and computing the square with the denominator s minus 1 square plus 1. Now, I'm going to apply the first shift. So, what I'm going to do now is shift s minus 1 to s. So, all the s minus 1 is replaced by s. So, this will become inverse Laplace transform of 4s plus 5 over s squared plus 1. After I shift s minus 1 to s, then I must multiply by e power t, since I have shifted s minus 1 to s by adding plus 1. So this is how you apply the first shift. So, after apply the first shift, this is equal to e power t times inverse Laplace transform of 4s plus 5 over s squared plus 1. This inverse Laplace transform can be written as a sum of two terms. First, this is inverse Laplace transform of 4s over s squared plus 1 plus the inverse Laplace transform of 5 over s squared plus 1. And then you can pull out the 4 and pull out the 5. This will give you e power t times 4 times the inverse Laplace transform of s over s squared plus 1 plus 5 times the inverse Laplace transform of 1 over s squared plus 1. And now you take a table. What is the inverse Laplace transform of s over s squared plus 1? You find that Laplace transform of cosine at is s over s squared plus a squared. So a is equal to 1 now. Therefore, the first term we have e power t times 4 cosine t, where a is equal to 1, plus the second term 1 inverse Laplace transform of 1 over s squared plus 1. This is referring to the table here. You find that Laplace transform of sine at is a over s squared plus a squared. Here a is equal to 1. So this is equal to 5 times sine t. This is how we get the answer of example 12.